Hello, my name is Jan Fester. I'm happy to have you here for this webinar on BW and BPC and their relationship with SAP Predictive Analytics. And I'm presenting today with Rao. We'll be touching slightly on also future-looking topics, so be aware of this disclaimer. But without further ado, let's jump directly to the agenda. So the plan for the day is to look very briefly at SAP BW4 HANA and especially in how it relates to predictive in general. Many of you will be much more BW experts than I am. I'm really focusing on predictive analytics, but there's a certain deep necessity between both products to work together, and that nicely fits really also from both products. And after having delved onto this, the main part will be really on what you'd been expecting, so the integration of predictive with BW4, especially on showcasing a couple of very concrete scenarios on how this will be done. I'm trying to be quite technical there and really going down to the object and code level to give you a good feel on how this would be happening. We'll not be demoing things, but all the items will be screenshotted, and so that you have full information, such as to essentially start your own project with this or reach out to us for further questions. And after those first two items, Raul will be taken over to showcase how the integration with BPC would work. So, enterprise data warehousing, all of us in enterprise software know how important this is. I want to look at this on why this is so important for predictive. What we love in the predictive world about enterprise data warehouses is that they have clean data, centralized data, reliable data, and lots of it. Lots of historical data, and it's really the go-to place for reliable information. And this is very much what predictive needs. There is a good, nice saying that without data, there's no data mining. So, and obviously, without good data, there's no good data mining. And enterprise data warehouses aim exactly at solving this data quality issue, and this is very much a natural fit for us from the predictive end to then take these findings and this reliable, cleansed data to enhance it and to find the patterns that make it even more interesting for you. Looking at concretely SAP Business Warehouse, not only enterprise data warehouses in general, lots of customers entrust their central enterprise data warehouse with us, and the growing part of them is trusting in the power of having BW on HANA or even BW4 HANA. All of what we're saying today applies for both BW on HANA and BW4, but obviously since BW4 is the more the product that we are focusing especially on. All the slides will be looking at BW4, but be aware that BW on HANA is really working the same way from a predictive angle. There's a long history of BW integrating tightly with HANA, and this is and in a way that predictive can leverage it the best, and we'll see this shortly. That predictive looks at objects on a native database level, and really only with the BW on HANA family, and later on then BW4 HANA, all your objects could all your BW objects could also generate their counterparts in on the database level, and this is where PA or Predictive Analytics for short comes in. So you might have seen these at various events already, what BW4 HANA is aiming to achieve. So simplicity, this is also a shared value for us in predictive. In predictive, we're focusing very much on making the journey from data to running model very smooth and simple. don't make it a black art or mad mathematician's art, but something that the everyday lay interested data analyst person can really achieve, and all the more so if the data is of a quality that you would have in an enterprise data warehouse. Openness is a big thing on the BW front, which helps us, as I already mentioned, a lot, since we leverage this openness from the predictive analytics front. Modern interface, same for predictive. We are more and more on a journey to rejuvenate our UIs and following Fiori principles and making it in a up-to-date look and feel, and also high performance. That's very much at the core of what PA also does, is leverage the power of HANA both from the BW front, but predictive calculations are also oftentimes very critical performance-wise, because we are digging through so much data, and so pushing your algorithms very much down to where the data is, meaning HANA, is very much what we strove for in architecting the predictive analytics solution as well. If you have looked at BW4 HANA rollout sessions, this slide might ring a bell as well. So over the long-standing history of BW, a lot of objects have been invented where there possibly are certain overlaps or certain specialized usages of the individual objects. And now with BW4 and the brave decisions that could be taken by introducing a new product family, the object model has become a lot more clear-cut now, so that there is a clear way of how of what objects are used for persistency and which for virtualization, and really stripping things down only to these 4 bare minimum objects that are very, very clear and dedicated to that task. Now we are already coming closer to the predictive side of the house, because those 4 objects, since the advent of BW on HANA and also with BW4 HANA, all of these can, if you set a single switch on your modeling environment, can be generated into those calculation views, and that are identical from a data standpoint, from a behavior standpoint, and everything from a handling standpoint. They can be considered equivalent entirely to their BW counterpart. And since predictive is very much, or predictive analytics has its roots very much on the database front, this is where the integration now happens. You see further to the right, let me enable quickly my mouse so that it stays visible. Oops, screen, printer, arrow options, visible. So apart from those generated ones, you can obviously formulate additional ones that bring in additional data, that might be adding additional calculated columns, additional aggregations, also on top of these. And all of these are available through SQL, and this is, as I said, where predictive looks at things. So very brief on BW, as I said, and now let's dig deep on the integration piece here. So from a mere positioning and product family standpoint, obviously the business objects family is the natural, or we say default option for doing analytics on top of both BW and S4, and comprising both business intelligence, enterprise performance management, and now our brainchild for today, the predictive analytics. This slide is very important because it's going to be a reference slide throughout the talk from now on. So let's read it from left to right. The first 3 columns essentially you already saw. So BW generating its objects into the HANA formats that themselves are either consume calculation views, or you can build additional HANA artifacts on top of that. Now predictive analytics kicks in. And predictive analytics is a whole suite of tools that connect to this BW world, to a HANA world, and give you the means to formulate predictive models, hence dig in this data and learn from it. And once you learn from it, take the structures that you found and formulate predictions. So online connection here means directly accessing the data, plus, and this is really can't be stressed enough, doing the calculations. And as I said, predictive data mining, predictive machine learning is oftentimes a very, very number crunching, effortful, and this is all being pushed down to the HANA level. So the predictive analytics suite tells HANA how to look for patterns, what to dig for, what my target is, what the type of functions I try to use, and then HANA does it all and takes over. And this is why it's so lightning fast. Now, once all this digging has happened, you would be having a model, and at the end of the day, a model is nothing more than a complex mathematical equation. And this complex mathematical equation is formulated such a way that can easily be executed on HANA straight away. And this is where predictions comes in. So you learned in the past from patterns of how customer purchasing behavior was, how employees leaving us churn behavior was, how customers' reactions to marketing campaigns was, how retail store patterns were, all of these. And you look at the past, try to find what drove that behavior and capture this, and now on yet unseen data, leverage this knowledge to do the predictions. That's the whole, that's the cycle that we always have in mind. And now these predictions would then either materialize or be calculated virtually, but happen in HANA, and then the HANA artifacts, like here calculation views, would take these predictions, materialize them or calculate them on the fly, and have them as an HANA object. And the next step to take this HANA object is then to encapsulate it or to carry it over to the BW world, and there make it a standard info provider that would then be beefed up with those predictions. So you would have your historical sales pattern plus a forecast on how well sales evolve, what products can be expected to be bought together, what customers should be approached for the next marketing campaign also. But all enriching the data that you already have with additional information that the machine found for in these patterns. Another technical way today to integrate is to leverage the so-called HANA analysis processes. That is a technology that has been in BW for quite some time, with the idea that there is an info provider, something that works on the data in this info provider. And this can be a function module, a procedure, something else, working on this data and piping the output into yet another info provider. So this would be an alternative way of achieving a very similar thing, but being even more closely tied to the BW world in a way. So our predictive analytics suite would calculate a model based on that info provider and spit out a model, hence this potentially complex mathematical equation, and so that there you can then it surfaces as a procedure, and HANA analysis processes are able to consume procedures. So take the data from an info provider, hand it over to a procedure, and the procedure output hand that output over to an info provider. And this procedure can do anything HANA can do. Can do text mining, can do spatial analysis, can do predictive analytics library, which is the library within HANA that has all standard textbooks algorithms nowadays implemented are, of course, being closely being our way of achieving essentially limitless analysis possibilities through all the algorithms that are and the academic community supporting it have. And where our heart is very dear to is these automated procedures, so automatically mining the data and automatically finding that model. That is oftentimes from a time and effort to value perspective, oftentimes really the best way forward. At the end of the day, what this slide is trying to say, you can, by virtue of predictive analytics, build a procedure, and this procedure can be readily consumed in HANA analysis processes. If you have looked at HANA analysis processes, a lot of this will be sounding familiar. For the rest, I will be showing very in detail slide on how this interaction goes. Now, as promised, let's look into a couple of very concrete scenarios on how such an integration could happen. Scenario one, predictions on a regular basis. What could that potentially mean? Imagine you are a retailer and you wonder how many people will be coming to my stores next month, next week. How do I need to plan my staff accordingly? How many products will be sold of this type? How many of them do I need to source, and so on? And because time moves forward, this is something that needs to be done regularly. It's not that this is a time-crucial thing that I need the answer now. So oftentimes it's smart to take the data and then do additional calculations on top of them and persist them. So we've been working very closely with consumer products companies, for example, beefing up their market research data, for retailers, customer loyalty cards data also. And this is data that evolves over time and where you don't need an answer right now, but you want to do such a prediction regularly. In predictive maintenance, we see similar scenarios. No need to calculate right on the fly, but regularly, a similar model at regular intervals. On the other hand, there are definitely cases for real-time analytics. An example that directly comes to mind is fraud, for example, where imagine yourself being a bank or otherwise handling customer transactions that where it's a bit unsure whether these will eventually be fulfilled or not from the customer end. So they're having a very fast turnaround on, okay, here's my credit card ATM retrieval or so, and I wanna react in milliseconds to the individual transaction. This is obviously a case where such a direct interaction makes sense. We've seen similar scenarios for used cars pricing, for example. Customers submit in their transactions the specifics of a car and expect a price back. And so this is oftentimes, where as soon as the transaction is really of that type, real time is a necessity. And then sometimes you want to really be even closer to your BW transformation flow, and this is where HANA analysis processes will be your aid. So, as I said, this slide that we had earlier on is resurfacing in this way or the other. So, for scenario one, the left-hand side we've already looked at a couple of times, and now on the right-hand side you see an odd new beast that we call Predictive Factory. Predictive Factory is our tool as part of the Predictive Analytics suite that essentially is a repository of models. So thinking is there always that imagine you found a good model. And now you want your data scientists to move to the next big problem and make this solved problem an IT problem. So you essentially check in that model into Predictive Factory, and Predictive Factory takes care of managing that model, managing versions, managing checking whether the model is still accurate, retraining if necessary, and obviously applying this model regularly. Also potentially multiplying this model out. We see this a lot in time series. We have a big retail customer who's saying, okay, we need accurate predictions of bread, because if bread is a cent product, but if we don't have bread at the bakery at the entrance of our stores, if we don't have it in the correct quantities, people will go next door. So we need we need this prediction: how much bread of these types will be sold in what store tomorrow, and so all of these will be different models, because the rye bread sells different than the wheat bread in store A, different than store B, and so these will be many models, and managing them is an own task by itself. And here we are back at SAP home turf, making things enterprise ready, and so taking the model that was once developed as a template and multiplying this out along a multitude of stores and a multitude of in that case, bread types or product types, product categories also. We have similar cases with manufacturers who are saying, okay, I need to regularly calculate my production demand, and possibly by product category type, by product type. I want to regularly call, Cisco does this. They want to do their sales pipeline analysis, but by product category and region and customer category. So this easily means a lot of models, and this is why we felt it is necessary to come up with a tool that manages this multitude of models. You could also call it a model manager at the end of the day. And this Predictive Factory hence is taking those models and is repeatedly executing them alongside a schedule that you define. And then what it does, it obviously, while training those models or retraining, it pushes things back to HANA, and all the delegation happens back to HANA. But once the predictions are need to be calculated, so concrete scores, a concrete timeline, a concrete forecast or so shall be generated. There is one important area, and I hope you're seeing my mouse, in the corresponding screens of your Predictive Factory that is saying, okay, whatever I calculated for the future, where do I write this to? And here you can fix it and say, okay, there is a table destination, some HANA schema, and a concrete table name, and I'll write my scores, my predictions into that table, and you can be sure to find them at this schedule. Because they are written to a certain place, BW can pick them up and easily then use standard means in HANA to join these predictions with the historical data that you use for model training, that your dashboard users eventually will need in the query, so whatever. So here, standard HANA modeling kicks in, because at the end of the day, this is not just another table. And you can easily bring this together. And if you're fancy, you can take this HANA artifact and expose that as an open ODS and composite provider. And Dao and me are, as we speak, developing the material for TechEd this year to show this live for hands-on that you might want to visit and participate in. That goes through exactly those things here. So, looking at slightly more detail even, so the model training, as I said, the pattern finding, the weight finding, model training is a step of its own, and for that we need the data that live in BW, but they're exposed in as external HANA views. So there, as an external HANA view, we can talk to them from the predictive end. So Predictive Factory is aware of that view and allows you to specify a model, or you can use any other tool in the Predictive Analytics suite, like Automated Modeler or Expert Composer or so, to formulate such a model, but they will all share the same HANA source data. And then factory will be writing predictions into a HANA table. So then because it then is HANA data, natural HANA data, it can be beefed up. That was the bottom left bubbles on the last slide, can be beefed up as a HANA object. That joins historical and data and predictions, so your old data and your forecast or so. And obviously BW can then consume that same data or that same view in an open ODS or composite provider. That's already it. For scenario one. So I'll go back here. So if you want to generate predictions on a regular basis, you're on safe turf, use Predictive Factory to generate data into a given table, and BW will pick it up from there. Next scenario, if you remember correctly, we talked about real-time embedding. So to that end, you would typically train a model and encapsulate this model into something that is, obviously when you want to calculate something at runtime, you need code to do so at runtime. So you need some way to produce this code. And the easiest way for doing this for models is to use the predictive suite and the automatic model training and generation capabilities that are in predictive analytics for creating such code. And to that end, we introduced in the release of last November the Predictive Analytics 3.1 a feature that you can generate any model into a so-called UDF function, a user-defined function that's a HANA artifact. And this HANA artifact can be taken. It's just a function at the end of the day, but it contains all the weights that are required for doing a prediction, and you can take this function, call it from a calculation, from a scripted calc view, and then take this view, it's yet another view, and consume that in HANA. So let's look at this in slightly more detail. Model training as before, you have your info provider as a HANA view, your training is based on this HANA view, and you generate a user-defined function from that. That's just in our tool set a possibility of training a model and taking that model outcome as a unified function. That is just physically code, and you'll see that in a slide in a second. So that user-defined function is code. It's a create function statement, so you can execute that, and the privilege will be those of this repo user. And after that function, yet another function, but the one that does the predictions. And so you can do standard HANA modeling and standard BW modeling for doing so. So I'll quickly go over slides that pick that in detail. Since we'll be sending out the slides, you can take this as reference. It's becoming techy in the next 5 slides, but for you for reference and to make it a bit more tangible than that, what you would typically do is you have your BW object that is a calculation view. You have your UDF function that was created by your predictive analytics tools, and you will build a joint information, new objects, taken the information from the historical data and your function to have both in one place, eventually consume them in BW. So what would this mean? In your PA tool, you choose that you want to generate the code, that you want to generate your model into a UDF function. So what is that? It's a UDF function. I'll quickly, for time reason, I'll quickly step over this. So it's a bit of comments telling you, okay, how would you eventually use that function, and then it creates a function. And it creates a function that is called claims fraud score that takes a couple of input parameters and eventually returns an output. And an output is a score. And it does so based on the different weights that the incoming parameters have. And these weights is exactly what the model building essentially computed. There's nothing here that you would read a lot because it's just a math function. Now this you can execute. So you can take this create statement in your HANA console, and then it becomes just another function, an object in your catalog. And then you can take, and this is the slide with the 5 bubbles here. You can take your original data, A, that you learned upon, and your new data that takes that data and beefs it up with predictions and create a new calculation view from this. And so you would take your data plus. So this is your calculation view, and now you would beef this up in a scripted calculation view that calls, and now this string might sound familiar. This claims fraud score is exactly the name of the UDF function that you created earlier. And so there is a new field. This is fraud score that is part of this new HANA view. And at runtime, it will run through all this weight matrix and find that score and call it is fraud score. So, and then if you carry it back into BW, you take that score and make it yet another field in your BW object, and there you have it. So, and if you then inspect that new info provider using standard BW means, you will then have your insurance fraud probability and potentially other scores that were calculated with it as part of your BW entity. So there and then all the analytics, all the BI that you want to put on top, all the usage, there you're absolutely free. It's all the heavy lifting is happening in this UDF function. So let's check my watch again. I'll need to speed up slightly. I see, since we want to have also questions for or time for question and answers, but I didn't want to skip on that. So here now we're talking HANA analysis processes. HANA analysis processes are, as I said, a means of connecting two info providers and doing transformations underneath, typically in the form of HANA procedures. Now, how would we do that? There are 2 ways of bringing this HANA procedure into being. Either BW generates a skeleton for you and you fill it with life, or the procedure is there beforehand and you wire it into the HANA analysis process. So here is a user-defined function that is generated from a HANA, and you call it from a HANA analysis process. So model training as before, really very much as in step number 2. You generate the user-defined function, you execute it in your SQL editor, it is then there. And then we either take the, and now in this transaction, in this HANA analysis process transaction, you generate a procedure skeleton and from there call this generated UDF function. And afterwards, any HANA analysis process has a data target, so something that scores are being written to. This can then be forwarded on to a composite provider or to yet another data transfer process, or even a HANA analysis process for this matter. So very quickly, you have your HANA analysis process, you have your source, your procedure, and your target. And now you're saying, okay, I want to there shall be a procedure, and I want to generate it. And so it generates it. It's taken all the fields, pushing them as a data source, pushing them down, and then a coding window opens in the procedure window, and there you can do whatever you want. Like, for example, talk to the HANA the user-defined function that this other procedure that we generated in the last step, and just call that. So it's a procedure wrapping another procedure. What you would then do, now we're on tab data target, you just map what comes out of the procedure and map it on to where do you, what do you do with it. And here in the MA_FP, you see that an auto insurance fraud probability is now being handed over as well. An alternative way is to not generate the procedure from the HANA analysis process, but to take a procedure that you already have. So so there the procedure would typically come into being because you feel very familiar with SQL coding. So, and there you have the full freedom of SQL coding in your SQL console with all the goodies that HANA gives you with text and spatial and PAL and automated and R and so on. And this procedure is following certain naming conventions, and you can call and build this in. So let's quickly jump over this as well. So in this here, I need to obey to a certain signature, obviously, otherwise HANA analysis process can't talk to it. So here I'm writing a read-only procedure that takes some in tab and writes some out tab, and these are structures that have been defined. And my data set in this case is really simple. It's just a timeline and a level. So imagine a very simple time series that is happening here. And what that happens is that I would have, in this case, I'm doing a forecast. A coded procedure that I did earlier on that takes all these configuration tables and eventually spits out a result. And this result is then handed over to the out tab that the procedure gives outside. So and because ABAP requires capital names for fields, it's a prediction level, and this I take from the result tab. So here all the real modeling or the maths part would be happening in here, but that's standard PAL APL coding, and the documentation will be your friend for this. What is interesting is that this is an out tab now, and this out tab, and now it's the same screen for analysis process as before, but it's not a generated procedure. It's a managed procedure that we declare here and that we start now wiring into the HANA analysis process. So we register it and say, okay, how does the parameters of my procedure, how do they map to parameters that my one info provider and my second info provider have? So I'm mapping them here. I'm still on my data source here. Here I'm doing my mapping on my data target, and on my data target I'm doing the same thing, and then I can execute that on activation and take this composite provider here and look at that. And so here I now have my measurement data and my predicted level from my time series. So, and with that, I'd like to hand over to Rao, who will quickly run over the BPC slides.
Thanks, Jan. Okay. Thank you, everybody. So what I'm going to show here is how it's a BPC predictive scenario. So in this situation, in this business case, so what we want to see is how predictive analytics can help BPC scenario. That is the business side of it. And the technical side of it, it involves BPC, it involves the predictive analytics, and it involves SAP HANA, several other components, and it has I will show you the architecture how we did for this scenario. And the business case here is we want to the business want to enable their users to make data-driven decisions using the machine learning-based time series forecasting, and increase their accuracy of the planning, and the predictions that can be used on the basis of forecast is in their basic BPC application. The background here is in the BPC, what you do normally is you take the historical data and then you use different ways and means to start your planning, and it's primarily gut-based planning. So what we do here with in the scenario we are trying to do is the predictive analytics can give you a more accurate forecasting, and then if you start your planning scenario with the results of the predictive, so you can get a better planning results. That's the goal of it. We have this all technical systems. So I want to give a quick thing is in this scenario. So what we are doing is let's imagine a company having hundreds of products, and it is pretty difficult for anybody to manage the models for each product line or each product, and integrate with the integrate with any planning solution. So what here to do is we have the ability to do the segmented forecasting in the predictive factory. So what it does, you forecast on a single product and then you segment it based on given key or given set of keys. So that way, when you start one product and you can go with the multiple, you can segment it into the different levels and different granularities depending upon your models. And the other feature in the predictive factory is the predictive factory can save the predictive factory can you can schedule the forecasting and model training and everything in the background. So even if you have hundreds of models, you can schedule in the background, and the results can go back. Results can be saved into BPC HANA, and these results are going to be the feed for the BPC. What here I'm trying to show the architecture as a simple architecture. There are many ways to do this one. This is one of the way we want to show you, how the whole scenario works from the process side of it. So here, what we are looking at is we have a historical data, and historical data is in HANA, right? And then you can predict using the predictive factory, and the results are saved to the HANA table. Okay, and what you can do is you can create a wrapper for the wrapper with the wrapper in the HANA, and this will be exposed the predictive results, and you have an option to enrich the predictive results what you got from the predictive factory. And then you got to model in your BW. The BW, you can create an open ODS views that can fetch the results from the HANA view where the predictive results are. And the other side, you have the advanced data store objects where your real-time data is sitting in, and then you can build a composite provider, and then you expose after building the aggregation level, you can expose the data set to the planning layout. So now look what happens here. So what happens here is when the planner comes and opens his layout, what he is seeing here is predictive results combined with the real-time data, and then he can start his planning, and he can start his planning. That way, the whole that's where you are starting your planning with a more accurate data. So this is one of the options, and the second thing is we have a little bit of a interactive thing here. So what happens here is, as you are aware that BPC is a driver-based planning, and there are sometimes you want to have scenarios where you want to do some simulation, or do you want to give an extra focus for the particular products or product lines. So in this screen, this scenario is where the customer has a huge number of products, and he don't want to do all products interactively, but what he does is use good number of products or the majority of the products with a predictive factory, so that it use for the massive adoption of all forecasting results. And whereas the selected products, he want to do some simulation. So what you can do here is, what the user wants to simulate the predictions with certain drivers. Okay, so you imagine that here that is your BPC is modeled based on certain drivers, and then those drivers as a key inputs into your analytic application. For example, if you have one of your driver for your BP model is the price of oil. Okay, you can have the price of oil or price of the commodity as an input in the analytic application, and then by changing the price in the by changing the price in the analytic application, you can simulate the predictive results by calling the APL on HANA. So you trigger a simulation that goes to the APL on HANA, and then which gets the sales history, and then do the predictions and send the planning results back to the analytic application. So here the user have the ability to do certain simulations, 1, 2, or 3. Yeah. So he can do the simulate. He can simulate the several iterations, and then he can have the multiple drivers also. And so here once the user finalizes that simulation at particular combination or particular level of the price, he can save the results. So when he is saving the results, you can use the planning framework, the planning functions that are part of the BPC and HANA, and then you save the results back into the predictive, back into the BPC and the planning framework. Now, once we do this one, technically it goes to the same scenario where your predictive results are sitting in the HANA table, and then the same thing will work exactly the same fashion. So, and at the end, what the key benefits of this one is, with the predictive analytics, you can identify the business drivers. That is a very starting step, which is it's a part of the predictive analytics, where once you complete your model, once you build your model, you identify that it helps you to identify the business drivers, and those business drivers you use starting to build BPC models. And secondly, you get accurate forecasting results for the planning process. So you are, because of the ability of segmented forecasting in the predictive factory, you can forecast for all your products and product lines, and then send the results and get more accurate results for planning. And the mass enablement, again, it is a segmented. Again, it is a feature of the predictive factory to forecast hundreds of products, and they are managed by they can be automatically managed, and then it's a seamless process when you are using the embedded, and when you are using the embedded, it is a seamless process. It is between the PA and BPC. Whereas you want to use the standard models, there are some workarounds. Those workarounds would be like, okay, you can do the predictive factory, you can do the forecasting from the predictive factory and save the results to the database or wherever you want to save. And again, you can use the data manager functionality of the BPC to upload the forecasted data into the BPC. So that way, if you are using the BPC standard, that you can use it, and if you are using the BPC embedded, this is more seamless, and you can have more, a lot of other features that can benefit the planning process. Yeah, thank you very much.
So, Rao, 2 questions that came in very recently. T asked, is classic BPC supported with predictive analytics? And Fiola ideally answered, how can I execute the predictive procedure in the planning function? Rao, that's beyond me. Is that something you can take? Classic BPC supported?
Yeah, sure. So in the planning function, the idea here is when you are using the planning function, you can have the parameters, and the planning function has the area. Basically, let me step back. The APL, you create an APL procedure to do the prediction, and this APL procedure can be consumed in the planning function, where the planning with the planning function parameters. You can pass those parameters from the planning function to the APL, and the APL executes the predictive model and sends the results back. So that's the way the planning function it works. And again, the BPC, some question is coming up. Standard BPC are embedded. I guess the embedded is like a more native in nature. It is easy to monitor and easy to from the process side. But however, if you are using the standard BPC, you got to do some manual steps or some disconnected steps. That definitely you can do that one because the planning process is not that you are going to do on a day-to-day basis. So you can predict the forecasting, and then you can manually, or you can use the BPC's data manager function to upload your BPC side of the table, BPC side. So that's the one way you can do it. Yeah.
Okay. Then there's a very interesting question from Brian further up in the chat. While the architecture shows that business object on top of S4 and BW for HANA, it seems that it's actually just on top of HANA and not actually integrated with either product and application. Is that accurate? For S4, less so. With S4, we are building a product or using a product that is called Predictive Analytics Integrator, that is essentially an ABAP to HANA interim layer that we will be releasing to customers and partners for their own developments in the, say, next half year from current planning. For BW, you're completely right. And there I'd be extremely, we are currently in contact with BW with the BW development colleagues to make the actual interaction with BW entities and not the HANA entities closer. And we are looking for customer cases on what is most urgently required there, to go beyond the scenarios that we presented today, where you rightly state that we integrate on a HANA layer only, how to make it more BW-aware, make it BW, make things callable from transformations, make BW tap into predictive factory, model repository, publishing of models right into BW, all of these, but they're also for to assess best. I'd be extremely interested to learn from your requirements and possibly even schedule calls with BW development, PA development, and you customers for concrete ideas on how you envision such situations to be. There, I heavily invite you for feedback.
Thank you.
Thank you.